Again, and welcome to another version of Algebra 2 Notes with Miss Faust. It's good to see you again. It has been a while. And today we're going to be looking at some ways to factor a polynomial. Specifically, we're going to be looking at how we use special products and special rules when we're factoring. So we've done some factoring with boxes and some other things, but these three rules we're going to learn today just come up over and over and over and over in algebra and pre-calc problems. So there's special rules that go along with them. Again, it's a matter of finding patterns and some of those same things we've been doing. So the first thing, just to review, is a little bit of multiplication. So if we had something like a plus b times a minus b, in order to multiply that out, most of us would use a box, and we'd put a and b and a and b. And when we multiply it out, we get a squared here, we get negative ab here, because the order doesn't matter. Here we get positive a times b, and here we would get negative b squared. And hopefully what you can see pretty quickly in that is that the two things on the diagonal actually cancel out. A positive ab and a negative ab just leave you with nothing. So a plus b times a minus b is equal to a squared minus b squared. And that's the first generalization that we're going to use over and over and over in Algebra 2 and is going to be really useful. So it's kind of review because it's the multiplying, and then later I'll show you how you go back the other way if we start here and we want to get those back. So second example is a plus b times a squared plus ab. Oh, I messed up. Oops, oops, oops. That's a minus. A squared minus ab plus b squared. So again, when we think about multiplying that out, we would want to make a bigger box because we need a and plus b here. And then across the top we need three things. We need an a squared, we need a negative ab, and we need a b squared. So a squared times a, well, if we're multiplying, then the exponents go up by 1, and that gives us a cubed. This negative ab times a is negative a squared b, because we'd have two a's and a b. This one we have two b's and an a, so it's ab squared. This one, two a's and a b, so it's a squared b. This one negative a, two b's, so it's negative a b squared, two b's. And then finally, b squared and b give us a positive b cubed. So again, when we look closely at that, hopefully you can see that some things cancel. So if we look at this, we have a positive a squared b and a negative a squared b. Bye-bye. And we have, whoopsies, a positive ab squared and a negative ab squared. Bye-bye. And we're just left with this a cubed and the b cubed. And I know this isn't showing up super well, but it doesn't really need to because you want to know that it was there, but it canceled out. So when we multiply that all out, we get an a cubed and a b cubed. Okay, and that brings us to our last one, which is a minus b times a cubed, a squared plus ab plus b squared. So again, we make a box. Follow along with me if you want, or pause it. Come back and see what I did. A minus b, a squared, ab, b squared, a cubed, two a's and a b, an a and two b's, negative a squared b, negative a b squared, and negative b to the third. Oh geez, that didn't all show up, but there it is. Now you got to just check it yourself. Yay! Okay, so again, look at the diagonals. Notice that one and that one are opposites. Notice that one and that one are opposites, so they cancel. So when we look at this, all we are left with is a cubed minus b cubed. So those three things, and let's see if I have another color in here. So these three rules are what we call the special product rules. I know you can't really see it because it's green. That's not the point. The point is that you know those are the three important parts of this. So what we're going to do now, we're going to step back a little and we're going to look at some squares and some cubes, because that's going to help us when we have problems in this form really quickly get them back into these other factored forms. So now I'd like you to take a moment. I'm going to set up this next page. And just so that we have them, because we're going to use them again and again, I want you to list in your notes perfect squares, starting at 1 and going up to, what did I say, 12? Yeah, 12's enough. And if you want to do this on your own time, you know, you don't have to watch me do it. But you want this all on one page. We're going to come back to this again and again. And then for cubes, you can just go up to 10. Okay, so take a minute, stop and fill in this table, and then we'll go on together from there. Okay, welcome back. Hopefully you had a chance to fill in those squares and cubes. You can see that I went ahead and built my tables here. Calculator, copying them, whatever is fine. But just the more times you write them, the more familiar with them you'll be. And then the other thing I put at the bottom here that you can take a minute, and you want to copy this really carefully because the pluses and minuses are really important. And that is the difference of squares. I realize that's a little bit hard to read. You're used to that. S-Q-U-A-R-E-S. There we go. Difference of squares, which says a squared minus b squared equals a plus b times a minus b. The sum of cubes, cubes added, sum of cubes, a plus b times, pardon the bell, a squared minus ab plus b squared. And finally, the difference of cubes. A cubed minus b cubed is a minus b times a squared plus ab plus b squared. So these three things, what's going to happen is we're going to get problems in this form and we're going to need to factor them. And when we factor them, we just use these formulas. We figure out what the a and what the b is, and we just plug them all right into those formulas. So write these down somewhere, maybe bookmark that page, put a star next to it, something like that, so that you can come back to it quickly and find it easily, because these formulas you're going to want to use again and again and again. And let's look at how we use them. Why, Miss Faust, that's exactly what I was wondering. Can we please do some examples now? Well, if you insist. Okay, so what your problems are going to look like is, let me just get my examples ready here. Okay, so the way these work is you are given something that is not factored. So you might be given something like x squared minus 64. And what you want to think about when you see that, anytime you see two pieces like this, always think about whether these rules will work. So I put a star, and anytime I see two parts, I try special product rules. And the special product rules are those three things I just showed you on the last page. So I look at this and I realize that I have two parts. Both of them are perfect squares, and they have a minus in the middle. So because they're both perfect squares and they have minus in the middle, I know I can use the difference of squares rule. And in order to use that difference of squares rule, what I want to think about is I want to think about in this problem, remember the difference of squares says a squared minus b squared equals a plus b times a minus b. So I want to think about comparing this to this. So what's the a and what's the b? So in this particular problem, our a is just x, because the square root of that gives us the a. And our b, well, b is whatever squared gives me 64. So something squared has to give me 64. If I need to, I can look back here on my squares, I look for 64. Oh, and I see that 8 squared gives me 64. So my b is 8. Once I know that, I just plug in that a and b right into that equation. So x squared minus 64 equals, parentheses, a, which is x in this case, plus b, which is 8, times a, which is x again, minus b, which is still 8. And I've now factored that problem. Example 2, 100 minus 36y squared. So again, I look at this and I think, okay, I have two parts. I see this squared here, so that squared makes me think I bet I can somehow find square roots in this. And I can again use the difference of squares. Right, it's a difference because it's subtraction, it's a difference of squares because of this squared, and because 136 are both on my perfect square list. So 100 is right here, 36 is right here. So again, I want to think about, I'm not going to write the rule again because you have it right here, but I want to think about what the a is and what the b is in this particular problem. So when I'm thinking about that, the a this time, well, the a, right, the a is the square root of the first thing. So the square root of this first thing, the square root of 100, if I need to look back here, the square root of 100 is 10. So a is 10. And then the b, again, the b is something I square to give me 36 and y squared. So if I think about what I square to get 36, I need to square 6 to get 36. But then I also have this y squared. Well, if I square y, I get y squared. So my a in this part is 10, and my b is 6y, which means 100 minus 36y squared equals a, which was 10, plus b, which was 6y, times a, which is 10, minus b, which is 6y. And I'm done. Example 3, 8p cubed minus 27q cubed. So again, I have two parts. And I notice here, though, that I have a 3 instead of a 2. So because I have a 3 instead of a 2, I'm going to try and use something with cubes. And then to figure out whether it's a sum or difference, I look at the operation in between the two parts I have. So the first part I have is 8p cubed, the second part is 27q cubed, and I have subtraction in between. So this time I'm going to use the difference of cubes formula. And because I don't have that one written, oops, right here, I'm going to write it out. A cubed minus b cubed equals, see, I don't memorize these either. A minus b times a squared plus ab plus b squared. So that's the formula I want to use, and again, I want to think about what my a is and what my, whoops, I need more space than that, what my b is in this problem. So in order to figure out what my a is and what my b is, I have to do a little bit more thinking with cubes because they're cubes instead of squares. So I look back up here and I think about what cubed gives me 8. Well, what cubed gives me 8? I look on this and I see 8 is right here. 2 cubed gives me 8. So the number I need is a 2. And then what letter cubed gives me p cubed? Well, p. So that's 2p. Then for the b, what cubed gives me 27? 3 cubed is 27. What cubed gives me q cubed? Just q. So then I plug them in. So 8p cubed minus 27q cubed equals a, which is 2p, minus b, which is 3q, times a squared. So now I need to take this a, this 2p, and I need to square the whole thing. That's really important. That's the most common mistake, is people don't square the whole thing. I need to multiply a and b, so I need to do 2p times 3q And then to that I need to add b, which is 3q, also all squared. Okay, so these just have like one additional step in them because now I need to simplify this, and simplify that. So 2p minus 3q doesn't get simplified. 2p squared, well 2 squared is 4, p squared is p squared. 2 times 3 is 6, and p times q is just pq. 3 squared is 9, and I have a q squared left. Oh, geez, you couldn't see that. There you go. So example 3, 8p cubed minus 27 cubed factors into this. Again, noting that we're simplifying those after we plug in the a and b. One more example. Okay, one last example of these, and then, as always, y'all get more practice in class. So this one we have 64x cubed plus 1. Again, we want to think about whether we might have squares or cubes because we have two pieces. So I see this cubed, which tells me must be cubed. And I see this addition, so those two things together tell me I'm going to use the sum of cubes formula. And the sum of cubes formula, whoops, is the one that says a cubed plus b cubed equals a plus b times a squared minus ab plus b squared. So again, step 2 is to think about what my a is and what my b is in this case. B is the easy one, so I'll do that first. So what cubed is 1? Well, 1 cubed is 1, so B is just 1. A, I need something cubed that gives me 64. So something cubed that gives me 64. I come back here. I look at my cubes. There it is. 4 cubed is 64. So my A is a 4. And then what cubed gives me x cubed? Just x. So my A is 4x, my B is 1. Those are going to get plugged in all of these places, and then the whole thing gets simplified a little. So 64 x cubed plus 1 equals 4x plus 1, a plus b, 4x all squared minus 4x times 1 plus 1 squared, or 4x plus 1 times 4 squared is 16, so that's 16x squared. 4 times 1 is 4, and the x, and 1 squared is just 1. So my final answer is 4x plus 1 times 16x squared minus 4x plus 1. So this together with the factoring using the box method is going to help you factor all kinds of polynomials. And then we put that together with polynomial long division and we can do anything. So you don't have to do anything yet, just know that it's coming. Thank you very much. Have a wonderful day.